to change a percent to a decimal, we go quickly. We go whatever? 2 places to the left. So we're going to start here if there's no decimal point, and we're going to put it there, and then we're going to go 1, 2, which means, yes, we have to annex a 0. So the decimal becomes 0.06. It is 0 and 6/10. To go from a percent to a fraction, remember we write whatever the percent is, and we put it over what, Riley? 100, always. Always over 100 if you're changing from percent to fraction. Even if it's a number bigger than 100, even if it's like 5,280, if it's going as a percent, because you can have percents that big, it always goes over 100. Yes, sir? Would you have to simplify that? Yes. And then we would be simplifying. So in this case, we're dividing them both by 2, becoming 3 over 50. Yes, you would simplify them. Correct. Remember the general rule that if they're both even, you can always at least simplify by 2, if not something else. Okay? The ratio, 6 to 100, you can also write it this way. Obviously, you can also write it in the fraction format, which we've already done. You can also write the ratio with the reduced fraction, which is 3 to 50. And if we were to make a model, we're not going to make a model, but this is one of those 100 grids. How many squares would you have colored in on the 100 grid? Riley? No. Hands. Ever? 6. Because it's 6 out of 100, so 6 squares shaded. Okay, because you always shade from whatever's the top. So you would have one 100 grid with 6 squares shaded. I need to remake these so that they actually have the 100 grids. That would be good. The next one is 60%. So to change it to a decimal, we're going to go left 2 places. Boom, boom. So we have 0.60, which we put the 0 in front. You can also have 0.6, and that's still 60. Remember that, especially if you're using a calculator, they lop off that last 0. That last 0 doesn't change its value, so it goes away. If you're talking percent, it's got to come back. If you're talking money, it has to come back, for sure. And then the other places depends on the question. So as a fraction, we get 60 over 100, which can be reduced to 6 over 10, 3 over 5. There's others. It could be 30 over 50. No, 30 over 50. It could be 30 over 50. Yep. Yep. Simplest form, 3 over 5. There are multiple ways of reducing it, but the final answer is 3 over 5. So then your ratio is 60 to 100, or 60 to 100. And you can have 3 to 5, 6 to 10. Those are all equivalent ratios. So if we had a 100 grid, how many squares would be shaded in on this 100 grid? Jasmine? 60. 60 squares shaded, which is 6 columns of 10, or 6 rows of 10. Okay, so you may see that. Again, this is the point of this is to show you all of the ways that percentages can be shown and written, including a picture. Okay, 600%, and yes, you can have 600%. Decimal point two, still to the left, giving you 6.00, can also be 6.0, or just plain old 6. Okay? If I'm telling you 600%, basically I'm saying times 6. So let's say yesterday I ordered 1 pizza. Today I want to order 600% more. You've heard of that. You've heard that in, like, if you're 110%, you've heard that, above 100. If I want 600% more than what I ordered yesterday, if I ordered 1 yesterday, I'm going to order 6 today. Okay? It's basically times 6. 500% times 5. Yes, sir. Correct. It is like getting a spelling contract with 105 points. Yep, you can go over 100. Okay? Basically, they're saying all of 1 as 100, all of the points, plus 5 extra. Or in this case, all 100 plus 500% more, which is 5 more copies. Yep, absolutely. You are still starting over 100. Still. But our percents are always over 100. Then we reduce it. Is that your question? Yes. Then you reduce it. It ends up being 6 over 1, which is just plain old 6. If you're doing a ratio, you'll probably leave it at 6 over 1 if you're doing a ratio. If you're, like, reducing further for some reason, it depends on the question, you might go all the way down to 6. No matter what, it's over 100. Okay, don't let that confuse you. Percents are always over 100. So it would be 600 to 100, 6 to 1, and again, you can write it in the, with a colon. And as far as the squares, what am I going to do with the squares? What am I going to do with the squares? Nathan? 6 full squares. You're going to have 6. You're going to have 6 100 grids, all shaded in. Okay, because this is 100%, that's 200%, 300%, 400%, 5, okay? Before, anything less than 1, you only had 1 100 grid. Now you have 6 full 100 grids. Okay, so if you see on your question you have like 6 squares where they're all filled in, that is 600. And then, I don't know why they randomly threw in the 32, must be just to show you that it works for everything else. So as a decimal, boom, boom, 0.32. As a fraction, 32 over 100, which then you can actually reduce by 4. You can go by 2, but you'd still be even again, so you have to go by 2 again. Your final is 8 over 25, but you would pass through 16 over 50. Again, if you can divide by 2, but then you have to make sure that you have finished, because dividing by 2 still gets you a number that can be reduced. And then your ratio, 32 to 100, or 8 to 25, or 16 to 50. And again, you can use the words. And how many squares are shaded in my 100 grid, Riley? 32. 1 100 grid with 32 squares. Okay? So basically, you should be able to take a chart like this, and I should be able to put one piece of information in a row, and you should be able to fill the rest of it out. Okay? If I give you a picture, you should be able to do the percent, the fraction, the ratio, everything. Like, bless you. If I give you the percent, you should be able to do the rest of it. Again, you should only need one piece of information because you can convert back and forth. Okay? And actually, it's very easy to convert back and forth for the most part, because most of the time you're just moving decimal points. Got her? All right, turn to page when you are ready. The next page is basically A review, remember when we did these a while back with double number lines? I kind of jumped the gun a little bit there. That actually is a tape diagram because it doesn't have the number line style with the arrows. Essentially, they basically look the same. It's just that the double number line has more of a arrowy piece to it. Either way, you can do it the same way. We've already done this. You basically start the top with 0 and 100 quickly. And then you divide based on the bottom. In this case, I was going into 4 parts, 20, 40, 60, 80, so I went 25, 50, 75, 100. If I was doing it, I could go by 10s, could go by 20s, I could go by 1s if I have to. Okay, it all depends on the rest of the numbers, how you draw this. And again, we've already done those. This is just kind of a quick review, how you can change back and forth, that kind of thing. Okay? So the next page for you guys is another reference page. Basically, all of the ways that we've talked about this. So in other words, if I give you an assignment and I say, all right, do it with a tape diagram, and you can't remember exactly what it should look like, this is where you go. Show me the tape diagram. Okay, boom, there it is. The only thing I don't like about their double number line is I don't like how their lines don't connect. I personally prefer it that way because then I know you're on the same line. See how they're like separate a little bit? But see how that looks like a number line, whereas the tape diagram looks less like a number line and more like a bunch of blocks. There's the 10 by 10 grid and calculations where you're changing things back and forth. Okay? All of those are ways to represent percents of a quantity. All right? And just like we did before, you're given part of it, and you have to, and with one missing piece, bless you, and you have to put them all in the right places, and then figure out the missing piece. Okay? So what we're going to do today is essentially the mathematical way of finding it. So, one more page. A lot of this is reference. Okay? Solving problems. Anything to do with percents. Okay? There are 3 parts to the question, and then there's a 4th part that's always 100. Okay? And this is kind of, this is the same as the ratios and the proportions from earlier. We have the whole, all of it. We have the part. We have the percent. And then the 4th is always 100. Always. Because that's what the percent is as a fraction. Over 100. So basically, if you are given a question, find 60% of 24. Find blah, 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 percent of blah, blah, blah. No matter what that is, you're always going to start with this ratio, or this proportion, you can call it. It has 4 parts. So essentially, before you even tackle any problem, you're going to start, remember I told you this before, start with your frame. You're going to actually add one more piece. If it has to do with percentages, your frame always has the 100. Okay? It's not going to tell you that. Before, remember, we set up the proportion and we said, we figured out like it was kilometers on the top and meters on the bottom or something, and we made sure that if we put kilometers on the top over here, we had kilometers on the top over there. Same kind of thing, except that this time that 100 is always, always there. So you need to memorize this formula. And it's everywhere. It's on the next page. It's on tonight's homework. It's on that one reference sheet I gave you a while back and said we'll finish working on that stuff. This is everywhere. And remember we talked about is and of. Is usually signifies the part of something, and the of is the whole. So 25 is half of, or 50% of 50. That's a bad example. 25 is, well, we want percent, is 25% of 100. Or it's the is whatever the part is. The of is usually whole, the whole. And then the word percent generally indicates the percent number, and you always go over 100. Okay? Sometimes the is will be written as like an equal sign, because that's kind of what it means. All right? So basically, what you're going to do, if you're tackling this problem, you first fill this out, like this, and then you find the three pieces. Okay? The percent is usually fairly easy to come up with because it either has the sign or it has the word percent. Then you have to figure out the part and the whole and use the words is and of as clues. And what you'll do is you'll fill in two of these, and then you'll use math to find the third one, the missing piece. No, last night's homework was just converting. So no, this isn't the same. So let's take a look at the next page. These are essentially the example, like what you're going to have tonight for homework. There's your formula. Is and of might help. Okay? Before we do this problem, 60% of 300 equals what? Tell me what part is missing. There's three parts. Remember, part, whole, and percent. What part is missing? What am I solving for? It's not the percent. There it is. What am I solving for, Ever? The part. Correct. The 60% is my percent. Of 300 means out of the whole 300 is blah. We don't know what it is. That's what we're solving for, is the part. Okay, so then to do that, again, before you tackle it, you should write that, no matter what. It should be the first thing you do. Okay, 60%. By the way, you're not, if you've changed it to a fraction, there is no percent sign. Okay, it is not this. No, not that. Okay, it's either 60% or 60 over 100, but you don't put the percent sign in the 100. All right? Because we've converted it. And we know the 300. And for now, I want you guys can use a question mark. Eventually, we'll start using variables, which are basically just letters that, we don't know what that is. So instead of putting a question mark, we'll put a letter. Okay? We're getting there. We're not quite there yet. So now, just like we've done before, you do what we know to what we don't know. Same direction on the other one. We go from 100 to 300 times 3, so we do times 3. So 60 times 3 is 180. So 60% of 300 is 180. And then you can kind of guess, well, half of 100, 50%, would be 150. So that's a little bit more than half. So yeah, that kind of makes sense. Okay? So the one on the right, what are we solving for? We have 60% of blah equals 300. What's missing, Jasmine? The whole. Correct. Because we know this is the whole of something. And remember, the equal sign can also mean is. 60% of something is 300. Okay? Now, before we go on, I want you to think about what your answer is going to look like here. All right? We're doing the part. So your whole is going to be bigger because it's only 60% of something. So your number is actually going to get bigger. All right? By a fair amount because it's almost half. So start your, again, you should always do that frame. We know the percent. This time we know the is, the part, and we don't know the whole. So again, what we know to what we don't know, same direction. To go from 60 to 300 is times 5, so this is times 5. 100 times 5 is 500. So 60% of 500 equals 300. Good. Yeah, the more we do it, the easier it'll become. Okay? And we'll get good at these before we start throwing in word problems. So, and the last one, 60 out of 300 is, what are we missing? What are we missing, Riley? The percent. Because we're basically saying 60 is what percent of 300? And remember what I said, it's always out of 100 and you're not using a percent sign. The of is the whole, the 60 is the part. Well, let's take a look. This is where you have to pay attention. Remember, you're going from what we know to what we don't know, and then the same direction. Now, how do we go from 300 to 100? We are, Caleb? We are dividing by 3. So we are dividing by 3. So it ends up being 20. So remember, that's not really 20. They want to know it is 20%. So you can't just tack a percent sign here and call it good. You actually have to rewrite it with a label. Okay? All right. Basically, I want you to just kind of chunk off a little spot. I want to show you one example. Some of my kids had some issues with this one. So I'm going to make one very similar. That should work. Yeah, that'll work. Okay, so do that. Put that down. Basically, it's saying 18 is 30% of what number? Okay. No, it's not 100. Now look, remember we go from what we know to what we don't know, what we know to what we don't know. Is there a number that we can, a whole number that we can use 30 divided by what equals 18? Is there a whole number? No. You cannot go directly from 30 to 18. So if that happens, remember we've done this before, you have to scale back. So basically, you look at it this way, you figure out, well, which one's the fraction that's there? In this case, it's the 30 over the 100 that we're going to look at. Okay? If there were numbers on here and the blank over here, then we would look at this fraction. Whatever fraction is complete, you're going to try to reduce it. So in this case, if I divide them both by 10, I get 3 over 10. Now, can I go to 18? Yes. Times 6 times 6. Okay, it's called scaling back. And we have done this. We did it when we did proportions. We've done it with equivalent fractions. So if you first see if there's a way to directly go there. And then if you can't, look at the fraction and figure out what can I do. Even if it's something like this. Okay, you probably should know this already, but B, just in case you don't know it, or just it's the process. Can I go directly from 14 to 10? No. Even if you have to go to where you have a 1, if it's something funky like a 7 or an 11 or a 5, you might have to actually bring one of these down to a 1 and then do back up. Okay? You may have to if all else fails. It's just like reducing fractions. Try to find the greatest common factor. You may have to do...
It's times 50.
Yes, you're right. It is times 50. So it's 50%, which you guys should have come up with already because it was 7 out of 14 is half. Question?
With the 18 divided by 30, would you be able to, well, I found a different way to do it. Like, I found the greatest common factor, then it
No.
was divided by
No, because,
because
well, you're using that. You are kind of using the greatest common factor in a way, but you're using it to say, well, if I do that, I can use that greatest common factor. It's not the same. It's not quite the same. I think your brain is thinking the right way. I think it's just you're using that piece. Kenny. Well, right now, because we've only learned how to do this with equivalent fractions, if you can't scale back and you can't figure it out, you need to check and make sure you haven't made a mistake. Okay? Eventually, remember how I talked about cross multiplying and cross products? Eventually, that's what we'll do to solve it. No. Nope. Your homework will be entirely, there will be equivalent fractions somehow. You may have to scale back. So if you're having problems, the first thing you should do is make sure you've set up your frame right. Okay? Because there is nothing that should be half numbers, decimals, nothing. We're not there yet. We will get there, but not yet. Okay?
I kind of don't want to get there.
Okay. Did you have a question, Jared, before? Okay. We are not going to do the back right this minute. We are going to, you're going to get your homework. Your homework is all these problems. I did put the formula at the top. I did not write the is and the of. You may want to do that. The answers to the front are on the back, and the answers to the back are on the front. Every one of these must be solved using this setup, this proportion setup with the 100 on the bottom right. Every one of them. Okay? I expect to see that first, and then I want to see arrows and numbers. And if you had to scale back, I want to see that as well. Jared, we need to stop doing that. Okay? Questions? Yes, ma'am.
Does Evan have this?
I believe he has this.
Okay, finish all.
Okay, I'm pretty sure Evan has this.